All right, Module 5, Navy Electronics Training Series, Chapter 2, Module 5. Direct current motors. Learning objectives. Upon the completion of this chapter, you'll be able to state the factors determine the direct rotation of the DC motor, state the right-hand rule for motors, describe the main difference, similarities between the DC motor, DC generator, DC motor, describe the cause and effect of the counter EMF in the DC motor, explain the term load as in pertaining to the electrical motor, list advantage, disadvantage, different types of DC motors, compare the types of armatures used for each, determine the means of the controlling speed, the direction of the DC motor, describe the effect of the armature reaction on the DC motor, explain the need for starting resistor of the DC motor. Alright, introduction. The DC motor mechanically workhorse that can be used in many different ways with many large pieces of equipment depending on the DC motor for the power to move the speed and direction of the rotation of the DC motor is easily controlled. This makes it easily used for operating equipment such as winches, cranes, missile launchers, which must move in a different direction with varying speeds. Principal operation of the DC motor is based on the following principle. Current carrying conductors placed with the magnetic field perpendicular lines of flux tends to move in the direction perpendicular to magnetic lines of flux. The definition relationship between the direction of the magnetic field and the direction of the current of the conductor direction of the conductor tends to move with the relationship best explained by use of the right-hand rule for motors, figure 2.1. Figure 2.1 shows the right-hand rule for motor's motion of the conductor current flux. So over the direction of the motion of the conductor, extend with the thumb, forefinger, to middle finger over the right hand, so that the right angles of each of the forefinger motion point in the direction of the magnetic flux in north or south. The middle finger is pointing with the direction of the current flow over the conductor. The thumb will then point in the direction of the current that will move. Stated very simply, but the DC motor rotates with the result of the two magnetic field interaction with each other. The armature for the DC motor acts like an electromagnet, which occurs when current can flow through its coil. Since the armature located with the magnetic field of the poles, these magnets feel they interact like magnetic poles repel each other, unlike magnetic poles attract each other. As in DC generator, the DC motor field poles have the stationary armature turning with the bearings in the space between the field poles of the armature. DC motor windings are just like the armature of the DC generator. The windings are thus connected to the commutator segment of the DC motor, so you can save the same components of the DC generator. In fact, the DC generators can be made as act as a motor as vice versa. Look at the simple DC motor shown in figure 2.2 with the two field poles, one north pole, one south pole. Magnetic lines forced to extend the opening between the poles of the north-south direction of the rotation. Application battery north-south, north-south. Also, the armature assembled DC motor is a single loop wire with just as a simple armature will shear the start at the beginning of the trap of the DC generate the loop of the wire DC. However, current flowing through the external source of the current caused by the magnetic field the field is indicated with the dotted line through the loop. The loop's armature field with the bolt attracts the propel with the field's poles. Since the current through the loop goes around the direction of the arrow of the north pole, with the armature is the upper left, the south pole is the armature is the lower right. Is shown figure 2.2a. View A. Of course, the loop of the armature turns. These magnetic poles turn with it. Now is shown the illustration. North armature pole is repelled from the north pole. The attracts with the right side of the south field pole. Likewise, the south armature pole is repelled from the south field pole to track the left of the north field pole. This action covers the armature of the turn clockwise direction, as is shown in figure 2.2, view B. After the loop has turned far enough to the north pole, exactly opposite of the south field pole, the brushes advance to the next segment. They change the direction of the current flow through the armature loops that has changed the polarity of the armature field, shown in figure 2.2, view C. The magnetic field again repels, and each other of the armature continues to turn. In simple motor, momentum with the rotating armature concerns for the armature path is position unlike pole, but they're exactly lined up. However, the fields are exactly lined up when the armature current turns on with no momentum to start the armature moving. In this case, the motor would rotate. It would not be necessary to give the motor a spin to start it. The disadvantage to do this does not exist when the motor turns the armature, because there's more than one armature field. No two armature fields could exactly align with the field poles at the same time. Or your counter EMF. If the DC motor is running, that acts somewhat like a DC generator. The magnetic field from the field pole loop with the wire turning and cutting the magnetic field for the moment. Disregard the fact that the current flowing through the loop of the wire and from the battery. As the loop cuts inside the magnetic field, the voltage is induced the same as the loop side. With the DC generator, this is induced voltage causes the current to flow on a loop. Now consider the relative direction between the current cause for the motor to run. For this, check for the direction of the current flow for the result of the generator acting to take place. The view A, figure 2.2, with apply with left-hand rule for generator to discuss later in this chapter. Usually the left hand hold its forefinger pointed to the direction of the magnetic field north and south, and the thumb and the points of the direction of the black side of the armature moves up. The middle finger over the points without the paper towards you, showing the direction of the current flow is caused by the generator action. Black half of the armature in the direction opposite over the battery current. Since the generator action voltage is opposite of the battery is called the counter EMF. The later EMF is amp with electromagnetic force with another name of the voltage. Two currents are flowing in the opposite direction that provides the battery voltage and the current EMF are opposite over the polarity. At the beginning of the discussion, we regarded the armature current with explaining with how the counter EMF was generated. There should be the normal armature current flow for the opposite, but the current created by the counter EMF would take the opposite current with the flow at the same time. However, this is a bit oversimplified, as you would already suspect. Actually, only one current flows, but the counter EMF can never become a larger amplified voltage because there are opposite polarities which have seen the counter EMF effectively cancel with the parts of the EMF armature voltage. Single current flows is armature current, but is greatly reduced because of the counter EMF. In DC motors, there's always the counter EMF developed. The counter EMF can be equal or greater than the applied battery voltage. If it were a motor that would not run the counter EMF always with a little less, however, the counter EMF opposed to the applied voltage enough to keep the armature current from the battery to very low value. If there is no such thing as counter EMF, much more current would flow through the armature, and the motor would run much faster. However, there is no way to avoid counter EMF. Alright, your motor loads. Motors are used to turn mechanical devices such as water pump, grind wheels, fan blades, circular saws. For example, the motor is turning the water pump. The water pump is load. The water pump is a mechanical device. The motor must move with the definition of the motor load. The electrical loads, mechanical load connect with the DC motor effect with many of the electrical quantity, especially the things power drawn with the line amount, with the current and speed, efficiency, etc., and are particularly controlled by the side of the load. The physical electrical characteristics of the motor must be matched to the requirements of the load. For the work is to be done without possibility of damage at either load of the motor. Practical DC motors. As you've seen, the DC motors are electrically identical to the DC generator, In fact, some of the DC machines may be driven mechanically to generate the voltage and may be driven electrically to move the mechanical load. While this is normally done, it does point out the similarities between the two machines. These similarities would be used in the remainder of the chapter and introduced in the practical DC motors. You will immediately recognize the series shunt and compound type of the motors as being directly related to their generator counterparts. Alright, your series DC motor. The series DC motor field with the series of the armature of the field is wound with a few turns large wire because the motor must carry full armature current. The circuit for the series of the DC shown in Figure 2-3. So for the series field with armature, this would be your series wound DC motor. The motor develops a very large amount of turning force called torque. This standstill becomes the layer characteristic. The series of the DC motor can be used to operate small electronic appliances, portable electrical tools, cranes, winches, hoists, or like. Another characteristic is the speed varies widely with no load, full load. The series motors can be used with a relatively constant speed required under conditions of varying load. Major disadvantage series wound related to the speed characteristics mentioned in the latest paragraph. The speed series motor with no load, the connected with increase at the point with the motor with the aim may become damaged. Unless either of the bearings are damaged, winding of the flying out of the slots and the armature, there's no damage to both equipment and personnel. Some loads must always be connected to the series motor before you turn it on. This precaution primarily for the large motors. Smaller motors, such as the electrical hand drills, have enough internal friction to load themselves. A final advantage of the series motors is that they can be operated by using either AC or DC power source. They will be converted into the chapter on AC, covered in the chapter AC motors. Alright, shunt motor. Shunt motor is connected the same way the shunt generator. The field windings are connected to the parallel shunt with the armature winding. The series of the circuit of the shunt motor, Figure 2-4, show the shunt field armature, the input voltage. Once added, adjusted, and once you adjust the speed of the DC shunt motor, the speed remains relatively constant with even under the changing load conditions. One reason that the field flux remains constant is the constant voltage across the field and the field independent various armature circuits. If the load of the meter is increased, motor tends to slow down. What happens to the counter EMF generally armature decrease the currents cause of the corresponding decrease of the opposition battery current flow through the armature. The armature and current increase because of the motor to speed up. Thus, the condition established original speed re-established original speed is maintained. Conversely, if the motor load is decreased, the motor tends to increase speed. Counter EMF increases the armature current decreases, the speed increases. In each case, that happens rapidly with the actual change of the speed of light. Speed is slight. This is instantaneously timed to change the rather large fraction of fluctuation in speed. Alright, your compound motor has two field windings shown in figure 2.5, with one of the shield shunt field connected to the parallel armature, and the other shield series field with connected to the series with the armature. For the shunt field, give the typical type of the motor with a constant speed advantage for the regular shunt motor. Series field gives an advantage being able to develop a large torque with the motor to start with a heavy load. It should not be a surprise that the compound motor of both shunt and series motors characteristics. Show the series shunt field armature, the series field armature on both compound wound DC motors. The shunt field in the connected parallel with the series field armature is called the long shunt, is shown figure 2.5 view A, and the otherwise is called the short shunt, is shown figure 2.5. Type of armatures: as the DC generator, the construction of the evening two type of armature. Brief the review of the Grammy ring, the drum wound armatures necessary to emphasize similarities between the DC generator and DC motors. Are your Grammy ring armatures constructed with winding insulated wire around the soft iron ring, a equal space of the connection that you made to winding each of these connection to the communicator segment. The brushes touch out with the top and the bottom segment, two parallel paths. Current will flow, one on the left side, one on the right side. These paths are completed through the top brush back to the positive lead of the battery. Communicator brushes rotation Grammy ring. To check the direction of the rotation of the armature, you should use the right hand rule of the motor. Hold the left thumb and the forefinger, the middle finger of the right angle, point of the finger in the direction of the field flux. In this case, left to right. Now turn the right tiny wrist and the middle finger point to the direction of the current flow for the winding on the outside of the ring. Note that the current flowing through the page away from you. Left hand windings on the out page towards you, and the right hand windings you. The thumb now point the direction of winding will move. The Grammy ring armature is seldom used in modern DC motors. The modern DC motors, the winding on the inside of the ring shield the magnetic flux would call the type of the armature and insufficient. The Grammy ring armature is discussed primarily to help you better understand the drum wound armature. Alright, your drum wound armature. The drum wound armature is generally used in AC motors, identical with the drum winding discussed in chapter on the DC motors. The drum wound armature will cut in half, and the end view of the cut would resemble the drawing in the view in figure 27 view A and view 27 view B side view of the armature and the pole piece. Note that the length of the conductor is positioned parallel to the face of the pieces, therefore each conductor of the armature cut in maximum flux motor field and efficient Grammy ring armature overcoming by position. Show the drum type armature, slot wedging, armature coil, magnetic field computers, unfield pole, field mill, armature computer, armature coils, and slot. Alright, the direction current flow marked with each of the conductor figure 27 view A is though the armature returning with a magnetic field. The dot show the current flow towards the on the left side, but the cross to show the current flowing away from the right side. Strips of insulation inserted with the slot, but to keep the windings in play with the armature spinnings as shown figure wedge of figure 27 view A. Alright, direction of rotation. The direction of rotation of the DC motor depends on the direction of the magnetic field, the direction of the current flow of the armature. In either direction field, the direction of the current flow through the armature is reversed. The rotation of the motor will reverse. However, both of these factors reverse at the same time. The motor will continue rotating in the same direction. Actual practice of the field excitation voltage reversed in order to reverse the motor direction. Ordinarily, a motor is set up to do the particular job that requires fixed direction of the rotation. However, there are times when necessary to change the direction of the rotation, such as the driver, motor, phone, a gun turret, missile launcher. These must be able to move in both directions. Remember, the connection with either the armature with the field must be reversed, but not both. In such application, the power connections are brought out reversing switch. Motor speed. Motor speed. A motor whose speeds can be controlled with is called a variable speed motor. The DC motors are variable speed motors. Speed of the DC motors change with the current with the field change with the current armature. When the field current is decreased, the field flux is produced. The current EMF that decreases. This permits more armature current. Therefore, the motor speed is up. The field current is increased. The field flux increases. The counter EMF is developed, in which opposed to the armature current decreases. The motor slows down. When the voltage applied with the armature decreases, the armature current is decreased, and the motor again slows down. The armature voltage and current both increase. The motor speeds up. In shunt meters, speed is usually controlled by the rheostat connected to the series of the field windings, as shown in figure 2.8. The resistance of the rheostat is increased with the current through the field winding, decrease the flux momentarily, decrease the current EMF of the motor, then speeds up to increase the counter EMF, keeps the armature current the same. Similar manner, the decrease of the resistance or increase of the current flow through the field windings cause the motor to slow down. This shows you controlling motor speed using a rheostat, shield field armature, or what was known as a variable speed motor. In series of the rheostat speed control may be connected with the either parallel and series of the armature winding. In either case, moving the rheostat in the direction of the lower of the voltage. Curl the armature low with current through the armature slow of the motor. Moving the rheostat in the direction that increase the voltage current of the armature and increase the motor speed. Your armature reaction. You will remember that the subject of the armature reaction was covered in parts of the previous chapter on the DC generator. The reason for the armature reaction method, the compensating for E effect of the basically sample. Same with the DC motor for the DC generator. The figure 2.9 reiterates the direction distorting effect of the armature field with the heads on the flux between the pole pieces. Notice how the effect shifted in the neutral plane backward against the direction of the rotating difference DC generator when the power neutral plane shifted in the forward direction of the rotation. Neutral plane, armature, magnetic field, and current communicator brush. As before, the brushes must be shifted in the neutral plane, shown figure 2.9. The shift is counterclockwise. Again, proper location is reached when there is no sparking with the brushes. Compensation windings interpole with two or more old subjects cause two or more old subjects cancel armature reaction in DC motors. Shifting brushes reduce spark, but also makes field less effective. The canceling armature reaction eliminates need to shift the brush in the first place. Compensating windings to interpoles are important motors as they generate the compensating windings relatively expensive and therefore more larger DC motors depend on the interpole for the corrective armature reaction. Compensating windings are the same motors as with the generators interpoles, however, they're slightly different. The difference is that the generators interpoles have the same polarity main pole ahead of the direction of the rotation of the motor pole, interpole with the same pole as the main pole following it. The interpole coal motor is connected with the carrier of the armature current, the same as in the generator. As load varies, the interpole flux varies. Communication automatically corrected as the load is changed. It's necessary to shift the brushes when they increase or decrease load. The brushes are located in no load neutral plane. They remain in the position with all the conditions of the load. The DC motor reverse direction of the current in the armature. When the armature current is reversed, the current through the interpole is also reversed. Therefore, the interpole still has the proper polarity to provide automatic commutation. Mutual and automatic starters. Because of the DC resistant motor armature, most motor armatures is about 500 to 5/10 of an ohm. Because of the counter EMF does not exist until the armature begins to turn. Necessary the external shafting starting resistance is here with the armature DC motor to keep the initial armature current to a safe value. The armature begins to turn the counter EMF and increase since the armature exposed the applied voltage. The armature current is reduced. The external resistance in series of armature is decreased with eliminated as the motor comes up the normal full voltage applied with the armature. Alright, controlling starting resistance DC motor is accomplished either manually by an operator or by any several automatic devices. The automatic device is usually just switches controlled by the motor speed sensor. Automatic starters are not covered in detail in this module. Chapter 2, Summary.